We are going to take a look at our pre-lecture notes to learn about graphs and what type of graph is best for what type of data. The first piece of our pre-lecture notes is to make a frequency distribution table. Very important here is what kind of data this frequency distribution table came from. So right here I have to the side that the data set was 25 grades. And so when I think about what would that data set look like, the data set would have just been a single list of data. And so when I have that single list of data and I don't have pairs of data, it's hard to make a graph to represent it. So the first way that we start to organize this is into a frequency distribution table. We divide the total range of the data, so this would have been grades from 60 to 99. And we would then go through the list of data. Every time we see a piece of data in a category, we place down a tally mark. So when you're doing homework, you'll see a list of data. My math lab will already have set up the intervals for you, so this will be determined. And you will literally just go through every piece of data. You'll put a tally mark for which class it's in. After you've been through the whole set of data, you'll count those tally marks. That's the frequency. You will often be asked to calculate the midpoint of the class. So let's take a look at that. The first class, the class goes from 60 to 64. The midpoint is 62, and we probably can do that math in our head. But let's take a look at how to do that calculation if we're not good at doing math in our head. So the way that we do that is we would take 60, the lowest end of the class, plus 64, the highest end of the class, and we'd take that answer and divide it by 2. So we would get 124 from doing the addition divided by 2, and that gives us the answer of 62. And we can do that for any class. It's quite possible that this midpoint will come out with a decimal depending where you're working. So depending on the numbers, it may be like 62.5. When you're in my math lab, the class intervals will be predetermined. You may have to calculate the midpoints. You may have to take a set of data and decide how it is distributed among the classes. When you set up your own frequency distribution table, there's a couple things to keep in mind. The first thing is that the classes must be the same size. So each of these, we see 60 to 64, 65 to 69, has exactly 5 values in. So 60, 61, 62, 63, 64, all in this class. Second thing we see is that the classes cannot overlap. So if our data had a decimal to it, we may have made this 64.9, and then the next one starts at 65 and ends at 69.9. Next one starts at 70, but they cannot overlap. When you're looking at a set of data and you're determining how many classes to make, you want to end up with between 5 and 20 classes. So this particular frequency distribution table has 8 classes, which is in that range. So a common frequency distribution table. When we have a frequency distribution table, we want to display it in a graph. The graph that goes with this is called a histogram. A histogram looks very similar to a bar graph, but the columns typically touch. When you're working on your project, you know to create a histogram when you have a single list of data. Now, when you're working with technology, the technology will sort the data into the classes. Typically, the histogram is labeled with the midpoints. So you see on my histogram, these are the midpoints of our frequency distribution table, and that is why those midpoints are found. And it just is a little bit less cluttered than putting all of the class intervals onto the graph. When you make a histogram, the number of whatever you're talking about, in this case student grades, is always on the vertical axis. You can see over here number of people. So that's always the case, number of, and then whatever you're talking about. Whereas the categories themselves are down here, and so our grades go down here, and of course we have a title. Our next type of graph is the actual bar graph, so very similar to the histogram. However, with the bar graph, we have categorized data, and so that's our most important thing here. So our categories in this case were the years, and we see them as every 5. And then what is measured for those categories is the thousands of barrels per day of oil. A couple things to notice. This data would be paired, so 1985 would have been paired with 60,000. And so it is not a single list, but it looks like a chart or table in the data form. It is really nice to put these labels on the top of our bars so that we know exactly how high up they go on the scale. It's not essential, but really nice. We have to have labels for each of the different axis. This one said year. It cut off a little bit there in my image. We have to have a title overall. When we make this numeric scale, it has to be an even scale. So you see each of mine are going up by 10,000. I can't just put these up randomly. Our next type of graph is the line graph, and I just drew a very small portion of the line graph. The line graph, again, has paired data. So in this case, a time was paired with a temperature. However, it must be continuous, whereas the bar graph can have categories. This one has to have numbers on both axes. So since time is numeric, temperature is numeric, this works for a line graph. The reason why we have to have those numbers is because in order to connect these, there has to be data values in between them. So between 12 a.m. and 4 a.m., this person had a temperature all of that time, and the temperature was continuous. It always existed. Then we get into independent versus dependent, and I'm going to actually talk about those two on the next slide. So typically, the horizontal axis is the independent. When you were back taking algebra, this would have been your x-axis. And then your vertical axis is your dependent. Again, when you were back taking algebra, this would have been your y-axis. Some other words that we can use there: independent is what you pick, it's the input, it's the cause. And then pairing these up, so if you pick this one, you measure the y. If this is input, y is output. If this is the cause, y is effect. We'll practice some when we go through the PowerPoint, but for right now, from the video that you watched as part of the pre-lecture, the independent, the one you pick, is how many times you eat at McDonald's. The dependent is your weight gain. It depends on how much junk food you eat. Next scenario, the number of gallons of gas that you pump, that's independent. You pick that. But then that determines, that is the cause for the effect, which is the amount you pay. And that is based on the number of gallons. Independent is the speed that you walk. And then how quickly you get home, well, that depends on the speed that you walk. And then with the lawyer, you get to determine how many hours that lawyer works for you. But once they've worked, the fee, well, that depends on how many hours they worked for you. So the dependent always depends on the other item. Our last type of graph is the pie graph or circle graph. When we look at this one, it is best for showing relationships of part to the whole. And it can only be used, note that only, when the categories add up to the whole. So we need a title. We need a title and a percent for each of these sections the whole way around here. And so this whole is the number of hospital discharges, and that's reflected in the title. That's the total. And then there's the routine, there's to long-term care, etc. Each of the categories, and each of the categories has a percent. Now, as review, if we need to calculate the percent, that's part over total, and then you would multiply by 100. And if we already know the percent, but we need to calculate how many are in that category, we would take the percent times the total to get the part. Now, it is common that the title includes a subtitle letting you know how many values are in the data set. So if we looked at 1,000 discharges, that is given because we need to know this total amount to use either formula. So when you make your graphs as part of the project, make sure that you're including in the title the n equals, the total number that is part of the data set. Next, we get to some of the common summary numbers. The first one is the mean. The mean is synonymous with the average, and you literally just add up all the numbers, divide by how many there are. We do get this strange looking formula over here, and we will talk about this more next week, so we're not going to worry about it a lot this week. X with the line over it, called X bar, is the symbol for mean. This goofy looking letter is the Greek letter sigma, and it means to add up all the values. X with the subscript I, which looks better here in typed than handwritten, stands for each piece of data. So this is saying add up each piece of data, and then N in statistics always stands for the number of data values, so divide by how many there are. We'll see some of those symbols on our calculator, but as I said, we'll worry about it next week. Median is the middle of an ordered set of data. So really important that you put the data in order, typically from smallest to largest, and then count in to find the middle. If you have an even set of data, you'll have two middle values, and you just add them together and divide by 2. So you take the mean of those values. The mode is the number that appears most often. So if everything is there once, we say that it has no mode. And if you have two numbers that are both the most often, we have bimodal data, and you literally have two modes. So last piece is finding the mean on your calculator. You can add up all the data values and divide by how many there are, but there is a pre-programmed function that will also calculate the mean. And the way that you get that on the calculator, the TI-30X-IIS that I recommended to you, is you first put your calculator in stat mode, which is the keystrokes second, data, and enter. And that puts you in one variable statistics mode. And the little stat word will show up on the bottom of your screen. Then you type the data using that data button and using the arrow keys. After each piece of data, it will prompt you for the frequency. How often does that data appear in your set? And then to find the mean, you'll push the stat var button and arrow over to X bar. Now, truly, you do not need to worry about that this week. You can find the mean by adding up the values, dividing by how many there are, without using the stat feature. If you want to play around with it, the keystrokes are the same for standard deviation, which we'll do next week. And for standard deviation, we want to use what's programmed into our calculator. But don't worry about it. Don't stress about it over break. We'll talk about this next week with standard deviation.